All right, this section 2.4, measures of central tendency. All right, here in the example it says AIDS data indicating the number of months a patient with AIDS lives after taking a new antibody drug are as follows, smallest to largest. Calculate the mean, median, mid-range, and mode. Okay, so each one of these are a statistic, and that is particularly because each one of those numbers represents a number of months from an individual that has AIDS that lives after taking a new antibody. I imagine this is not every per individual with AIDS, how they lived in the whole world, so this is just a small snapshot of that. So when we go ahead and calculate the mean, we'll actually figure this out. The symbol here, X bar, and that represents, the symbol represents that for the sample mean. So when we go ahead and calculate all this, it will, the symbol for that, the sample mean is X bar. So we'll go ahead and do that here. We're going to take and add up all the numbers. That's the definition of sample mean, just adding these all up. So plus 8 plus the 10 plus ... I'm going to skip down towards the end here. 47 plus 54. And I'm going to take all that and divide that by the total number of values in the sample. There are 26 numbers, so then that total divided by 26 is then going to represent for the sample mean. Alright, so let me grab a calculator and we'll do that. It just happens to be that the sum of all 26 numbers is 624. So finally, to wrap up this problem, the sample mean is going to be equal to 624 divided by the number of values, which is 26. And this is, by the way, we'll come over this in a second, that the number 26, it represented the letter N. That's a symbol that represents the sample size, the number of values in the sample. And we're going to go over the symbols for all these. This kind of did an introductory video there for this section, talking about mu and X bar. All right, so let me grab a calculator. We'll take 624, so 624, and then divide that by 26, and there we get the answer is indeed 24. But not just the number 24, we're going to label it with its units, which does represent months. So all these are going to have units, inches, centimeters, colors, things like that. You want to indicate what that represents for that. So that is the sample mean. Let's move on to the next one here for median. Median is the number in the middle. So of course, as always, I can't say enough that we need to order the set. Order sample. Without that, none of this would come together. So for convenience, it's already been put in order, so I just might as well come back over to the list here. And one thing to point out as I'm doing that, let me come back here for a second. You know their sample size, just go ahead and take your sample size and divide that by 2. So here, since we have the 26 numbers, divide by 2, and we get simply a 13. And we're going to go over these rules a little bit. But I want to count in to the 13th number. And actually, to add to that, if we have in this case an even number, notice we have 26 numbers here, so an even number of values in the sample. So our sample size is even. When that happens, more particularly, we're going to find the 13th number and actually average that with a 14th number, and I'll show you in a second why. So here for our list, let's go and count the 13th number in here. So we got 2 here, starting 2 the minimum. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this first 26 is the number 13, or the 13th value, and the one after it is the 14th value. But imagine here for a second you have an even number of values. Therefore, up here at the top, we have 13 values below the median, and then also we have above it 13 values above. So there's like nothing here, between those two numbers. And that's why I'm saying, you could even count it here, because even above it, like you've got, starting with the second 26, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 values above it. When that happens with an even list, you have to average the middle too. In other words, I'm saying take the 13th category, the 13th value, and average that with a 14th value here. So simply this math is going to turn into 26 plus 26 divided by 2. So again, if you have an even list of numbers, average the middle too. So let's come ahead and bring this down. You'll see that the answer is indeed 26. So therefore, we're going to take 26 in the 13th slot plus 26, which is in the 14th slot. Add those together, divide by 2, and you simply get 26 months. Varies a little bit different from the sample mean at 24 months. So that is how you find the median when you have an even list of values. In examples to come, and maybe even the homework, we'll look at what happens when you have an odd list. In the case like that, you just have to directly find the number in the middle. And that's kind of like the first example I did on the introduction. All right, so we got the mean, we got the median. Let's go ahead and move on to the next two. For the next one is the mid-range. The definition of mid-range is max plus the min divided by 2. Okay, so again here, this is the mid-range is the maximum. Actually, let me back up here. I'll just start with the min. Minimum plus the max divided by 2. This is precisely the same definition as a median. No, yeah, the midpoint. And you recall with the formula of the midpoint, like for each class, you take the lower class limit plus the upper class limit divided by 2. Don't subtract. So we subtracted those two numbers when we're trying to find the range. More particularly, what I'm referring to here is the min and the max. So careful that the formula here for the min range is this. So let's go up here at the top and figure out what those two numbers are. Now it looks like the min here is indeed the number 2, and the maximum is number 54, provided that these were already put in order. So let me indicate that here. We have the min is 2, the max is 54. Therefore, when you add those two together, you're going to get 56, and then you want to divide that by 2. And then here we get, so 56 divided by 2. Let's see. 56 is, so this would be 28. So more precisely, this is 28 months. Okay, 28 months is the mid-range. And the last one here is the mode. The mode is the number, let me put a note here, the value that repeats the most. It's the value in the set that repeats the most. Let's go back to that list and look very carefully about which number, let me get rid of all this jargon up here, which number in this list repeats the most. Just kind of examine all this here, and if you look very carefully, very carefully here, you will notice that 26, out of all of them, all the repeats, there's nothing else repeats as many as the number 26. Therefore, the answer is 26. And we'll simply say here it's 26 months. All right. So there you go. So they kind of roughly, let me just zoom out here a little bit. You notice that for the sample mean, the answer was 24. For the median was 26 months. The mid-range was 28 months, and the last one there for the mode was 26. They all kind of vary from one another, not too much here, But of course, they will vary a lot from one another, and it's called this thing called an outlier. And we'll discuss that when outliers really affect off the center number. But they relatively agree. You wouldn't necessarily want to average all those numbers, but you could roughly see there that the number of months they lived after taking this new antibody was seen to be about somewhere between 24 to 28 months there. Okay, so that'll do it here for this example. For this one, evaluating the number of months lived after taking the antibody for AIDS patients.